Okay, so again here, okay, what I want to do is we want to get the LCD for each of these three pairs of rational expressions. Again, you want to get it's good to get the LCD because when you add and subtract, you're going to need to get a common denominator. It's just like with fractions of integers. It's just like with fractions of integers. When you add and subtract, you need to have, okay? You need to have a common denominator. You have to have that, okay? So it's good to, so really theoretically, any common denominator will work. However, since we're going to simplify, the least common denominator is best. All right, so for the first pair here, let me get that laser thing. As you can see, all right, what we want to do is factor these denominators. So we have x squared minus x minus 6. And that's equal to x minus 3 times x plus 2, as you can see. Right? And how do we know? Well, and how did I know to factor it this way? Well, notice that there are 3 terms here, okay? 3 terms. So it's a trinomial. The leading coefficient is 1, okay? The leading coefficient's 1. And not only, and so that, and it's degree 2. So because of that, we want 2 numbers whose product is -6 and the sum is -1. What numbers do that? Well, how about -3 and 2? Not to mention also, I think someone actually reminded me of this earlier in the course. I don't know why I didn't mention it earlier, but the coefficient of the constant, the sign of the constant term, right here it's minus because we're subtracting. That tells you if the numbers are the same, are alike in sign or not. In other words, they're both positive or they're both negative. Here it's negative, so they're not going to be the same. One's positive, one's negative. The sign of the coefficient of x, here it's subtracting, so it's -1, so it's negative. That tells you what sign the bigger number gets. So in this case, the bigger number, which is 3, gets a negative. You know, it's just something else you can use to help if you want. You know, here we just needed 2 numbers whose product is -6, right? But the sum is -1. So that's why we get -3 and 2. Here, this is a difference of 2 squares. We have x squared minus 9. So we have x minus 3 times x plus 3, okay? X minus 3 times x plus 3, okay? So because of that, you know, we have x squared minus 3 squared, so we factor that. You can see that here we have x minus 3. The exponent is 1, right? So the only exponent of it is 1, right? We see it here and here. The only exponent's 1. X plus 2, right? The only exponent is 1. X plus 3, it's here, and that's it. And the only exponent's 1, right? Remember, you normally take the bigger exponent, but here, in each case, for each factor, the exponents are all 1. So this is the LCD. This is the LCD. Okay. And here all we had to do was get the LCD, so that's what we're doing now. Okay, so here again, we have x squared minus 5x plus 4, okay? We want to factor that. So we need 2 numbers whose product is 4, but the sum is -5. How about 4 and 1? But the sum has to be negative, right? So let's take them both to be negative. And also, if you use that thing I said before, since this is a plus, both signs have to be the same, right? In the other one, it was negative, so they had to be different. This tells us the bigger sign, or in this case, both have to be negative. So, if you want to do it that way, that's fine also. You could just remember that, well, we need two numbers whose product is 4, but the sum has to be -5. So it would have to be -4 and -1. Here, same idea, except now we want two numbers whose product is -2 and the sum is 1. How about 2 and -1? Okay. How about 2 and -1? All right. Okay, so here, now we can get the irreducible factors, right? So x minus 4, that's 1. That doesn't appear here. The only exponent of it is 1. X minus 1 is here and here. Both exponents are 1. X plus 2, the only exponent of it is 1. So that's here. All right. So altogether, the LCD, we have x minus 4 to the first, x minus 1 to the first, times x plus 2 to the first. Raising it to the first doesn't do anything, so we don't have to write that exponent. Okay? Again, it's each irreducible factor raised to its biggest exponent. All right. For this one, we want to, again, factor. We have x squared minus 25, right? Okay, so that's a difference of 2 squares, x minus 5 times x plus 5. Here, we have this. So we have x, here we have x squared plus 9x plus 20, right? So we want two numbers whose product is 20. The sum is 9. So 5 and 4 pull that off, right? You don't want to use 10 and 2 because they add up to 12. 5 and 4 add up to 9, so those work. So here, each irreducible factor, as you can see, right? So we have x minus 5, okay, raised to the first power, right? And that's not over here, no x minus 5 here, so the biggest exponent of it is 1. X plus 5, the exponents of it are 1, right? So the only exponent of it is 1, hence the greatest exponent's 1. X plus 4, same idea. The only exponent of it is 1. Good. All right. Okay, so our LCD is x minus 5 to the first times x plus 4 to the first times x plus 5 to the first, sorry, times x plus 4 to the first. Okay, so we have that. Are there any questions about these three? I did just email the notes. Okay. So that's great. We get the LCD. Well, now you might be wondering, well, what's the point of that? Although I did say earlier why. Again, we need a common denominator. Okay? We need a common denominator because when we add and subtract, the denominators have to be the same. That's where the common denominator comes into play. And just like when we're dealing with fractions of integers, right? To manipulate, you multiply top and bottom by the same number. You want to keep everything algebraically the same. So you can't just multiply the bottom by something and do nothing to the top. You have to keep everything algebraically the same, algebraically equivalent, excuse me. So we have A times C on top, B times C on the bottom. Okay, I mean, here, in other words, this is what we're going to use. It's just like with fractions of integers. Okay. All right. And then once the denominators are the same, we're going to add and subtract, right? Just like before, we only add and subtract the numerators. All right, so here. Okay, so for this one, right, we have 1 over x minus 2 plus 3 minus x over x plus 1, right? So here the denominators, they're not the same, right? We can't add yet, right? I've seen people make the mistake where they would add the numerators together and add the denominators together, even when they're not the same. Don't do that is what I'm saying. So the denominators are not the same. We're going to factor them. Okay? So from here, well, they're already factored actually, so it's a little bit easier. We get the LCD as a common denominator. Okay, so we have x minus 2, x plus 1. You know, and hopefully it's easy for you to see that the only exponent of each is 1. So the LCD is just the product, right? The only exponent of each is 1. So we get this. Okay? So this is the common denominator we're going to use. I mean, here the LCD is just the product, which is really cool. Okay? So we have 1 over x minus 2 plus 3 minus x over x plus 1, right? That's the original. We want to manipulate each one here so that the denominators are the same. So we have 1 over x minus 2 times, again, we want the denominator to be this product. Well, from here, we're missing x plus 1, right? We have x minus 2, but no x plus 1 here, so we're going to multiply by it. But again, whatever you do to the bottom, you do to the top, and that's what I'm doing here. And this actually becomes this. So, right? So now the denominator is this. Notice also that for the second one here, the denominator is missing the x minus 2. No big deal. We just multiply by it, and also the top by it as well. And we get this. Okay, now the denominators are the same, so now we can add. So we have x plus 1 plus this product. See? Like so. Okay? And here, actually, what I did was we FOILed, right? We FOILed. We have 3 times x minus 3 times 2. Excuse me, 3 times negative 2, that's minus 6, minus x squared. Minus minus is plus. When we add these, we get this. Okay, good. Let me pause the recording.